Differentiate y is equal to tan x. So if y is equal to tan x, then if we rewrite that as y is equal to sine x over cos x, then this is type u over v. It is a quotient, u over v, so therefore we can use the quotient rule to differentiate this. Because we know the derivative of sine, we know the derivative of cos. So let u be equal to sine x, then du by dx is cos x. Let v be equal to cos x, and then dv by dx is minus sine x. So using the quotient rule, which says that dy by dx is v du by dx minus u dv by dx. So v du by dx minus u dv by dx over v squared. So we got v, which is cos x. And then make sure you put this bit into brackets. So du by dx, which is cos x, again putting it in brackets, a minus sign, because the formula is a minus sign, times u, which is sine x, times dv by dx, which is minus sine x, over, so again, just to emphasize, to write the top term there all in brackets, over v squared, which is cos x, cos squared x. And then we got cos times cos, which is cos squared x, minus times a minus, which is plus sine squared x, over cos squared x. Now there's a temptation here to try to cancel this. You can't, because this is a common denominator. So we've got cos squared x plus sine squared x over cos squared x. Now we know from our trigonometry that cosine squared plus cos squared is equal to 1. So we'll replace that top numerator there with 1 over cos squared. And we also know that sec x is 1 over cos x. So therefore this becomes sec squared x. And the standard result is if y is equal to tan x, x in radians, then dy by dx is sec squared x. So this has been a video to show you how to differentiate tan x. Just one point now, you just use this rule in general. This is sort of the proof of the rule, which you would be expected to know how to do. Thank you very much for watching.